All right, in this video we're going to discuss fuel cells and also biofuels. So let's start out with fuel cells here. Now, if you don't know what a fuel cell, it's basically a device that produces electricity via an electrochemical reaction. In other words, a reaction where they are pulling electrons off of atoms and then getting those electrons to move around, and that gives you electricity. So the chemical part is, interactions of atoms, and the electro part is the electrons, and so they're getting that movement there. Now, the fuel they use for fuel cells is hydrogen, which happens to be the most abundant element on Earth. But we'll see why that's actually, while it is the most abundant, it's actually kind of hard to get in just a few minutes here. The byproduct, what's released by fuel cells, is simply water vapor. So pretty environmentally friendly. Now, water vapor is a greenhouse gas. Okay, we know that water does absorb heat, so you do have to keep that in mind, but you're not releasing, huge, vast amounts of it. Now, fuel cells can be used to do just about anything from powering buildings to even moving vehicles like buses. So it's a pretty nifty little device here. And this is basically what a fuel cell looks like. So you've got this picture down here on the left. And what you do is you take two hydrogens. Hydrogen gas is basically what you're using. So hydrogen gas is H2, two hydrogen atoms. And through a reaction, they pull the electrons off and they send them one way, up and around. And then they take what's left over, which is the proton. So, a hydrogen atom only has one electron, one proton in there. So they strip off the electron. They send the proton across a semi-permeable layer there. So they send it across. Think of it as a battery. Goes to the other side, and that electron wants to join back up again with its parent atom. And it's not allowed to cross that barrier. So the only way it can get there is to go up, around, and down. And of course, that movement of electrons around the fuel cell is what creates electricity. And so you see the light bulb at the top, that's what's powering that. Movement of electrons is what's powering the light bulb. And then when they get to the other side, you basically have the hydrogen that comes in, and that meets up with an oxygen molecule because the hydrogen is discharged. It meets up with oxygen, and it basically forms water. So up at the top, you can see protons are sent across over to the cathode. Cathode is the positive charge side. The anode is the negative charge side of the cell, and the electrons want to get back to the protons, so they flow around the circuit back to their protons, and they create energy in the process, or electricity. And they're fairly efficient, 40 to 50% efficiency rate, which isn't too bad considering that, when you put gas in your car, the efficiency rate of that's only 18%, so pretty efficient. So we do have fuel cell powered buses here in Coachella Valley. Sunline Transit has a hydrogen bus, and you've probably seen it around, and that thing on the top is the fuel cell that's powering it. There is also, Honda also has a car out there that's powered by a fuel cell. Now, I don't know if it's highly available to the general consumer or not. I haven't heard a lot about it. Now, the problem is getting the fuel for fuel cells, getting that hydrogen. Because while it's the most abundant element on Earth, it isn't easy to get by itself. It doesn't like to be a loner. It likes to be attached to other atoms. And so what we end up having to do is strip it off other things. And in order to strip it off of other molecules, that takes energy. So we have to put energy into it. And so that kind of takes away from how efficient it is. The two primary areas that we pull hydrogen from are from methane gas, that brown one there, CH4, and also from water. So they basically pull the four hydrogens off of methane gas, and you end up with a carbon over here by itself, and it ends up meeting up with some oxygen molecules floating around, and so you end up with carbon dioxide. So you are releasing a greenhouse gas simply by getting the fuel for your fuel cell. So while your fuel cell itself is not releasing the carbon dioxide, the process of obtaining that fuel is. So that's something to consider. And then you end up with four hydrogens, which are basically two hydrogen gas molecules to go in for the fuel. If you use water, you can strip off two hydrogens. The single oxygen goes up and meets with another single oxygen, and you get oxygen molecule as the result, which is good. And then you get the hydrogens that can go into the fuel. So again, at the bottom there, the energy spent stripping the hydrogen is what makes this process less efficient. So what are the pros of fuel cells? Well, it uses hydrogen, which is the most abundant element on Earth, so that's nice because we're probably not going to run out of it, and it's not burning it and consuming it. You still have hydrogen when you're left over, so you'll never run out of that resource. It only emits water vapor. There are no dangerous corrosives like in batteries. And it's rather versatile. You can use it in fuel, automotives, buildings, all different areas. It just depends on how large of a thing you're trying to power, and that gives you how large of a cell or multiple cells you are linking together. Now, the cons, you can see the list of cons is a little bit long on this one. The hydrogen that has to be stripped away from other compounds um, it costs a lot of energy. So you've got that energy consumption in the process of trying to get to the renewable energy. So that's a con. Fuel cells are potentially 80% efficient, but because of that stripping, you only end up with 40 to 45% when you factor all that in. And of course, hydrogen, it's in a gas form and it's really difficult to store in a car because it requires so much space. Remember that a gas is much less dense than a liquid. So if you're trying to save gas in something, you're going to have either a gigantic tank or you're going to have to be able to compress it down. So that having it being difficult to store and not being able to store very much at a time makes it less efficient in that if you put it in a car, you can't really go that far on it. And the biggest issue is that there's no national infrastructure. We don't have hydrogen supply, stations where you could go and fuel up your fuel cell. So getting access to hydrogen fuel is very difficult. It has to be obtained from special hydrogen fueling stations. Now, we do have a couple here in the desert over at Sunline because of our bus fuel cells, but you're not going to come across very many hydrogen fueling stations out there. So those are some of the negatives to fuel cells. All right, let's move on to biofuels. Now, this is probably one you're a little more familiar with hearing about, and there's basically two that we're going to discuss. The first one is biodiesel, and then there's also ethanol. So, biodiesel comes basically from using oils out of renewable resources, such as corn or soybean oils, and they take those oils and they break them down, and they basically get a diesel type substance that you can use in diesel burning engines. Ethanol comes from grain or other crops, and it's basically an alcohol. It's a grain alcohol. You can get it from corn, potatoes, sugarcane, wheat, sorghum, potatoes, I said, corn stalks, vegetable waste. And so what they do is they take this stuff, and just like, if you were a moonshiner, you would take it and grind it all up and put some yeast and some sugar in there, and you would ferment it, and you would basically create alcohol. And what they do with the ethanol is they actually mix it with your gasoline. They combine it with gasoline. And what that does is it increases the octane level, which makes the gas more efficient. It allows for more complete burning of the fuel, and that reduces the harmful emissions that are coming out of your tailpipes, such as carbon monoxide and hydrocarbons. So it burns cleaner and it's more efficient. You get more miles per gallon when you add that ethanol there. Okay, let's kind of focus on biodiesel. Now, biodiesel is made through a process called transesterification, and all that basically means is they're taking these fat molecules and they're breaking them apart and they're pulling out something called glycerin and they're taking that off and they're separating that from the fats and the vegetable oils. So in the end, you end up with a biodiesel, which is mostly those oils and all that, and then you have a glycerin. And glycerin is really commonly used in a lot of cosmetics like soaps and other things. So these companies that create biodiesel, they will break out this glycerin and then they'll sell the glycerin off to cosmetic companies that will use it in soaps and other things. Now, the nice thing about biodiesel is that it's a good way to recycle oil because you can actually go around to restaurants. A lot of the restaurants that have fryers, which just about everyone does, they have a receptacle behind there where they dump their used frying oil, their used vegetable oil. And then there's usually a waste company that comes and picks up that oil. And you can take that oil and you can filter out all the stuff and you can actually use it to create biodiesel. So it's a really good way of recycling and reducing that footprint. Biodiesel does cost more when you go to buy it from the pump, but it emits significantly less carbon dioxide and carbon monoxide and other less, and 85% less cancer causing agents. So it's kind of that whole mitigation thing. Yeah, it costs a little more, but you know it's the right thing to do, and so you're going to go ahead and do it. So Let's look at ethanol here. How do we make ethanol? Well, basically, like I said before, you take the grain or whatever you're putting in there. So in this case, it's corn. They take the grain, they mash it up, and they add some enzymes, some ammonia, and they allow it to ferment. Now, as it's fermenting, the bacteria are going through there and they're undergoing cellular respiration. They're eating all those sugars out, and then they're releasing carbon dioxide, just like you and I when we eat, and then we're burning that and we release carbon dioxide. So it's releasing carbon dioxide, so you do have a greenhouse gas being released, and then that's basically your product after that first fermentation process is beer. So you could stop there and have a drink, but they don't. Then they take it further and they distill it, and basically they cook it and they distill off, they evaporate off the alcohol in there, and that's your ethanol. And then they dehydrate it and they store it, and then they centrifuge all the chunky stuff that comes out. They put it through a dryer, and then a lot of times they will feed it out to cattle or other livestock, um, what have you. So you see the two pictures there. Now, you'll see the pump there. You can find places that will say like there's ethanol mixed in with your gasoline here, and so you know you're reducing your footprint that way. Now, one crop that they recently discovered they can use to make ethanol is something called switchgrass. And they have figured out they can use switchgrass to make it. And the nice thing about that is it has other benefits beyond just creating ethanol, because it really helps stabilize soils, prevents erosion, helps keep water in the soil. So it has many other benefits besides simply creating it for ethanol. And it being a grass, it grows rather quickly. So that has added benefits to it in itself. Another one that we can use as an oil alternative is algae. Just like you get vegetable oil, algae has oil in it as well. And so they have discovered that they can grow algae. This guy created these basically these plastic pockets that you hang in a greenhouse, and you grow algae in these pockets, and they let the algae get to a certain maturity, and then they pull them out and they spin it around and they centrifuge the algae out, and then somehow they separate the oil from the plant matter, and then they can use that oil and send it through transesterification and basically use that to create biodiesel. So you have a lot of different sources of oil that you can use in order to create biodiesel. So quite a few options and some interesting things out there. All right, let's look at pros and cons. The pros of biofuels is that it reduces our need for our fossil fuel oils. So that's a good thing. It reduces that pressure on them. They also burn much cleaner than fossil fuel burning cars and other machines. In fact, a friend of mine took his car and he converted it into a biodiesel car, and when it starts up and it's burning through its oil, and he actually just goes to like Costco and buys these giant vats of vegetable oil, and that's what he uses to fuel his car. um, it's funny because his car smells like French fries. I mean, that's the kind of smell you get out of it instead of that nasty like fossil fuel smell. It can be blended with fossil fuels and makes it for better combustion, better gas mileage. The biofuels can. You can use waste matter to make biofuels. Okay, so if you're harvesting corn, you can take the stalks and all that and munch them up and use that to create your ethanol. You can use switchgrass in certain climate zones, and that's really nice because it adds nutrients to the soil. It provides habitat for species. It's got a real nice tight root structure, so it prevents erosion and helps hold moisture in the soil. All things that we really need to consider as climate change progresses. Now, some of the cons: converting the fuel source into fuel requires just about as much energy as the final output. So you really don't end up in the plus. You kind of end up like, just even. And then ethanol cannot be a complete substitute for gas because there isn't enough land in the US to grow enough corn. And in fact, we've seen corn prices go up because as ethanol went up and there was a higher demand for it, people started growing corn for ethanol instead of for food, and you saw the price of corn go way up. So that's something, and that's why we're starting to look to other sources, and we're realizing, hey, we can use switchgrass, we can use potatoes, we can use these other things. So that's good. Major losses of habitat to grow more sugar cane and corn. Okay, so you also had a lot of people going out and buying up land because all of a sudden there was this big demand for ethanol. So they'd go buy up land and plow out these grasslands to plant in some crops so that they could make some money. And then you've got a lot of habitat loss. So we kind of had the very startings of what we had initially in the Midwest with the Dust Bowl. So you got to keep an eye on that. The other problem is that you have monocropping. When you're planting the same crop over and over and you're not using different crops and adding legumes and changing up the soil, then you will really quickly deplete the soil nutrients and cause a lot of erosion and cause some sterile soil. So you want to make sure that you're rotating crops through. We don't want to encourage this monocropping because that's not how ecology designed its system to work. All right, well, that ends the lecture on renewable energy. So go back through there, review everything. Let me just do this so you're not staring at my screen. Review the pros and cons to each of them, understand the sources, where they come from, and how they work, and you should be pretty well set for the final in that section. So our last set of videos is going to be on human population. So I'll see you for that.